Hello there, Mr. Sutton here, bringing you the AB Calculus 3-9 Part 2 homework solutions on tangent lines and higher order derivatives. For this problem, we're told that f and g are twice differentiable and h equals f of g of x. We want h double prime of x. So we're involving second derivatives and chain rule in the same problem. In order to get h double prime, we need to first figure out h single prime. That is going to involve the chain rule. So we're going to do f prime of g of x, so the derivative of f of something, times the derivative of the something, so times g prime of x. This is literally the chain rule written out as a formula. But now we have to go one step further. We have to do h double prime of x, which means we need the derivative of all this stuff. This is a product, so we're going to have to use the product rule. So let me set up my box and ribbon here. I've got one factor that's f prime of g of x. That's going to be fun to deal with. And then we have the other factor, g prime of x. All right, well, f prime of g of x, that is another chain rule. So the derivative of the outer function, that's going to just be f double prime of g of x, times the derivative of the inner function, so g prime of x. Next, derivative of g prime, that's just going to be g double prime of x, so that's not so bad. But now we have to actually multiply it all together using the ribbon. So I've got f double prime of g of x times g prime of x times another g prime of x. Well, g prime of x times itself, we can say g prime of x squared for that piece of it. And we still have that f double prime of g of x in the beginning. Next, we're going to add f prime of g of x times g double prime of x. Nothing we can really do to simplify that. I'm not really sure there's really anything else we can do to simplify this in general. So let's look at our answer choices and see if we have a match. So we need f double prime of g of x times g prime of x squared. And it looks like that's going to be answer choice A, especially if you look at all this other stuff. Everything is matching answer choice A. For this problem, we're given the first derivative of some function, and we want to know the second derivative. Now, there's a lot of places to go wrong on this problem. A big one is trying to take the derivative twice of this thing. Keep in mind, you've already got the first derivative. You just need to do one more derivative. So let's go ahead and rewrite this in a form that's easier to differentiate. So I'll write this as parentheses 1 minus y squared to the 1/2 power. So now I can go ahead and use my power rule. That's going to be 1/2 times all of this stuff to the negative 1/2. But now I have to use the chain rule here. So I need the derivative of the 1 minus y squared. 1 is just going to be 0. Negative y squared, that's going to be negative 2y that we're multiplying by. And here's the other place where a lot of people go wrong on this problem. We also need the derivative of y. Y is an inner function. How do we know this? Well, because it's dy over dx. This is all differentiated with respect to x. So anytime you're differentiating a y, you have to use implicit differentiation and have a dy over dx tail for this. All right, let's clean this up a little bit now. So I've got, with this negative exponent, I've got a fraction, so a numerator and a denominator. All of this stuff is moving downstairs to be with the 2. We'll take care of that in a sec. In the numerator, though, I have this negative 2y, and I also have this dy over dx. But there's no dy over dx in the answers here. So we actually have to substitute for dy over dx. What is dy over dx? Oh, they gave it to us up here. It's the square root of 1 minus y squared. So let's put that in our numerator. All right, now in the denominator, I'm going to have a 2. I'm also going to have the square root of 1 minus y squared. That's what this negative 1/2 means, square root in the denominator. And of course, this is none of the answer choices, so we have to simplify a little bit. This is nice, though. The 2's are going to cancel out, and we're also going to cancel out these radicals. That just leaves us with negative y when the dust settles, which is answer choice B. On this problem, we're given this derivative here, and we want to know the third derivative evaluated at x equals 2. So they typically don't go beyond the second derivative, but if you think about it, if you're starting at the first and you're ending at the third, you're just taking 2 derivatives. So let's get the second derivative out of this now. That's going to be, using our power rule, 4x cubed. And I'm just going to use f double prime here. I don't feel like using Leibniz. And then minus 6x squared plus 3. And now our third derivative, which I'm just going to write as f triple prime, that's going to be 12x squared minus 12x, and the 3 gets differentiated away. And now we have to actually plug in 2 to this function here. So we've got 12 times 4, which is 48, minus, this is 24 here. 48 minus 24 is 24, giving us answer choice B. On this problem, we want to know for what non-negative value of b is this y equals negative 1/3 x plus b normal to the curve y equals x cubed. All right, so we basically need to figure out where this line crosses this curve at a perpendicular slope. And if we have the x and the y value of that point of normalcy, which also happens to be the point of tangency, then we'll be able to plug in x and y and solve for that magical v, the b value. So let's start, since we know what the slope of this thing should be and what the slope of this thing should be, let's start by setting those slopes equal to each other. So I need the derivative of y here. That's going to be 3x squared using our power rule. And I also need the derivative of this function. I actually need the line perpendicular to this is slope. So the perpendicular slope to this, since the original slope is negative 1/3, the perpendicular slope is going to be the opposite reciprocal of that, so positive 3/1, or just positive 3. So I need to know where 3x squared, the derivative of the original curve here, equals this normal slope of 3. So let me set those equal to each other. And if I divide by 3 and square root both sides, I have x equals plus or minus 1. Now, I can't eliminate either of these x values right off the bat. They didn't say that x or y had to be non-negative. They said that b had to be non-negative. So we have to plug this in to our answer choices, or we have to plug this into the original curve to get y values, and then plug the x and y values into this thing to get b values, and then, whatever b value is positive, that'll be our answer. So let's plug this into the original curve here. If x equals negative 1, then we've got negative 1 cubed, which is also negative 1. So that gives us the point negative 1 comma negative 1. Now, if x is positive 1, well, then y equals positive 1 cubed, which is also positive 1. So we also have 1 comma 1. Let's go ahead now and plug both of these into this equation. So for negative 1 comma negative 1, we can write this as negative 1 equals negative 1/3 times negative 1 plus b. So this is negative 1 equals 1/3 plus b. And if we subtract that 1/3, we get negative 4/3. Well, they said b had to be non-negative. So this answer, which already kind of looked suspicious because of the negatives, can be eliminated. Negative 1/4, or negative 4/3 rather, can't be it. So let's plug in 1 comma 1 now and hope we get a non-negative b value. So at 1 comma 1, we can rewrite this equation as 1 equals negative 1/3 times 1 plus b. So essentially 1 plus 1/3 to get the b value, which is positive 4/3. So that's going to end up being answer choice C. On this problem, we're given y equals 2 cosine of x over 2. We want this is the second derivative here. So we need to take the first derivative and then take the derivative of that derivative. First derivative, we're going to have, let's see, this is a chain rule involved here, 2 times cosine of something. So that derivative would be negative 2 sine of something, sine of x over 2. But then we have to multiply by this inner tail. This is really 1/2 x, so the derivative of that is 1/2 that we're multiplying by. And I'm going to go ahead and clean this up and simplify it before I take another derivative. I like to simplify as I go because less simple things don't give us simpler derivatives. So 1/2 negative 2 cancel. That's negative sine of x over 2. Let me go ahead now and take the derivative of that. So this is the chain rule again. We have negative sine of something. That derivative is going to be negative cosine of something of x over 2 times the tail, which is again going to be 1/2. So this is just negative 1/2 cosine of x over 2, which is going to match answer choice E. On this problem, I've got this crazy equation here with a dy over dx in it, and I want the value of the second derivative at the point 3, 0. Well, to get the second derivative, it sure would be helpful if I knew the first derivative. So let me isolate dy over dx. Now the good news is they kind of did a lot of the work here for us. All we have to do is just divide by x plus 2y. So really not that bad of a process. So dy over dx then is just 2x minus y over x plus 2y. And unfortunately, there's no way to reduce or cancel anything. So this is what it is. Now we need to take the second derivative of this thing, the derivative of the derivative. So for that, I'm going to need a quotient rule. So let me go ahead and use my box and ribbon. And I've got my numerator of 2x minus y, denominator of x plus 2y. And now their derivatives. For this one, I've got 2 minus the derivative of y, which since I've got a y in here and this is dy over dx, that means I have to implicitly differentiate when I'm using a derivative of a y. So this is going to give me a minus dy over dx. Over here, derivative of x is 1. This is going to be plus 2 dy over dx. And I could go ahead and multiply this out and actually write the second derivative and then plug things in. But it would be easier just to plug this point in inside the box and then reassemble things out here. Now you'll notice that we have x's and y's and dy over dx's. So in order to plug everything in that we need, we're going to have to figure out dy over dx. One thing you could do is substitute 2x minus y over x plus 2y for the dy over dx, but that's actually a lot more work than you need to do. If we just figure out the numerical value of dy over dx at 3, 0, like I'm about to do here, we can just use that number instead of dy over dx. So plugging that in, we've got 2 times the x value 3 minus the y value of 0 all over the x value 3 plus 2 times the y value 0. So these zeros are just gone. We just really have 2 times 3 over 3. 6 over 3 reduces to 2. So now I've got a few things to plug in to the stuff in my box here. I've got an x value of 3, a y value of 0, and a dy over dx of 2. Plugging all of that in, this is going to be, let's see, 2 times 3 minus 0, which is 6. Up here we've got 3 plus 2 times 0, which is just 3. Down here, this is going to be 2 minus the derivative of 2, or the derivative value of 2. So 2 minus 2 is 0. And here I've got 1 plus 2 times 2, which comes out to 5. Now I'm going to use the ribbon to put it all back together. So I've got, just using u prime v minus uv prime over v squared, I've got 0 times 3. And we're doing the value of the second derivative now at 3, 0. So 0 times 3 minus 6 times 5 all over 3 squared. This is the v. So that's going to be, let's see, 0 minus 30, so negative 30 over 9. And I can reduce that by 3's. That's going to be negative 10 over 3. And that is finally going to give me answer choice A. On this free response problem, we're given the curve y cubed minus xy equals 2, and they're told it can be shown that dy over dx is this expression here. First part, they want an equation for the line tangent to the curve at the point negative 1, 1. Well, they've really been nice to us on this one. For a tangent line equation, we need an x value and a y value, and they gave those to us right off the bat, so that's nice. We also need the slope. Well, we need the slope of this equation, which would require implicit differentiation, but hey, look over here. They gave us dy over dx, at least the formula for it. So all we have to do is plug this point into this formula to get a slope, and then plug all that into point slope. So let me evaluate dy over dx at negative 1, 1. That's going to be the y value 1 over 3 times the y value 1 squared minus the x value of negative 1. So we've got 1 in the numerator. Downstairs, this is really 3 plus 1, so 4, so 1/4. Plugging that in with our point now, we've got y minus y1, so y minus 1, equals our slope of 1/4 times x minus x1, so that's going to be x plus 1. And that's done. For this next part of the problem, they want the coordinates of all points on this curve at which the tangent line to the curve to that point is vertical. If we want a vertical tangent line, that means that dy over dx does not exist, that we're basically dividing by 0. So we have to set our denominator equal to 0, 3y squared minus x equals 0. and solve that for x and y values. Well, there's a whole bunch of x and y values that make this true. So we're actually going to end up having to solve a system of equations involving this equation and, of course, the original curve, because it needs to fit inside that original curve to prove that it's on the curve. So let me start by isolating x. There isn't really much else I can do here, but I can at least get x by itself so that I can substitute for x back in the original. So let me just add x to the other side. So we know that x and 3y squared now are the same exact thing. Plugging that back into the original, I can write y cubed minus 3y squared y equals 2. So just plugging back into the original here. So this is really y cubed minus 3y cubed equals 2. Subtracting these, because these are like terms, that's negative 2y cubed equals 2. I can divide by negative 2 to get y cubed equals negative 1. And then if I cube root both sides, I see that y equals negative 1. All right, so we've got a y value. Let's plug that back into here to get the x value that goes with it. So that's going to be, let's see here, 3 times negative 1 squared equals x. So that means that x equals 3. And that means we have 3 comma negative 1 as our point. On this problem, they want the value of the second derivative at the point on the curve where x equals negative 1 and y equals 1. So this is the point that they actually asked us to find a tangent line for in part A. And remember, we found a slope of 1/4 back in part A. So just jogging your memory here, because that's going to be useful later on in this problem. In order to get the second derivative, though, let's take the second derivative of this first derivative, or actually take the second derivative in general, which means taking the derivative of this first derivative. This is going to require the product rule. So that's u prime v minus uv prime over v squared. Let's use the box and ribbon on this stuff up here. We have a numerator of y, denominator of 3y squared minus x, and their derivatives, which are using implicit differentiation, dy over dx. This is going to be 6y dy over dx minus 1. And now I'm plugging in the x value, negative 1, y equals 1, and from part A, dy over dx at this point, which was 1/4. Plugging all that in, we've got y, which is just 1. This is going to be 3 times 1 squared minus negative 1, so 3 plus 1, which is 4. And dy over dx, again, we said that was 1/4 from part A. This is going to be 6 times 1, so just 6, times 1/4, so 6/4 minus 1. Well, that's really 3/2 minus 1, which is just 1/2. Using the ribbon to put all this back together, we've got 1/4 times 4. And by the way, we're evaluating our second derivative now at negative 1 comma 1. So we have 1/4 times 4 minus 1 times 1/2 all over 4 squared. You could leave it like this. This is a free response problem, and this is numerically equivalent to whatever the real answer is. But if you really wanted to simplify it, this is going to be, let's see, 1/4 of 1/4 of 4 is just 1. We're doing 1 minus 1/2 basically, so 1/2 in the numerator. We have 16 in the denominator. Multiply by the reciprocal of 1 over 16. That's going to be 1 over 32 for our final answer.